guys, I'm back with a video. This is another video about wear or cutter compensation, if you will. G40, well, G41, G42, and turning it off with G40. Now I got stumped in the last video. I thought I was going to run wear. My post processor burped out a little error, and I didn't know what was going on. So I've done some research since then. I just milled a part. It's in the mill right now, and I'm ready to try this again. Now I've got two parts that I'm going to do this, and I've got well, I guess two experiments. This first part I'm going to run computer. From my understanding, computer in Fusion 360 is I keep the tool library, the cutter dimensions updated in the tool library, and when Fusion 360 calculates that tool path, right, in the manufacturer workspace, it takes that radius into account when you're doing, you know, all your roughing passes and most importantly, your finishing pass and my contour pass. Now this step here, this is the contour that I'm going to be experimenting with wear. With this particular die, I'm going to update in Fusion 360 in the tool library. I'm going to update the diameter of the tool I used for this, which was a 3/8 inch end mill. Okay, I'm going to update that, and then I'm going to run it again. And actually, before I do that, I'm going to run a spring pass. Okay. Now mind you, in Fusion 360 to start with, I made sure that I started with a blank 3/8 inch end mill size, 0.375 inches. Okay, not adjusted. Don't have no clue how. I know the end mill is worn a little bit because I've used it before, but I put it at 375 so it would calculate there, so it should be big. Okay, first I'm going to do a spring pass and remeasure and see the difference between a spring pass and then the initial milling. And then from there, I'm going to update the tool library, run it again, and remeasure. And well, I say we, but I'm practicing using in computer in Fusion 360 to effectively do cutter compensation. All right, so first things first, let's go ahead and run a spring pass and remeasure it. So right now it is milling a very slight step on the top of this die. And not taking away much. I think it's actually either a quarter of a millimeter or it might be half of a millimeter, 0.5 millimeters, and 1 millimeter in. All right, here's the contour in question that I want at 40 millimeters. And I came up with, you know, as conservative a speed and feet as I could for this is 52/100. And it sounds like it's engaging at the top of this die a little bit. Not much in the lower left quadrant though. That's interesting. This was my first measurement after my my first op. Okay, 40.028 millimeters. Okay, I'm going for 40 millimeters. This is after the spring pass that we just saw. That's 40.02 millimeters. So we're moving in the right direction. Okay, so I just need to make up 0.02 millimeters, and or at least prove that I can move in the right direction, because I honestly don't want to be below 40 millimeters. So I'm going to make a small adjustment in Fusion 360, okay, in my tool library, and then we will redo it and hopefully see a change. So let's go into the tool library. I have this library in the cloud because I have multiple computers that feed this. I've got flat end mills already selected, and I've got my 3/8 end mill right here. Okay, so let's go ahead and edit that. And under my cutter information, I've got 525. Now I want to make. Now remember my error. I was big by. Oh, where is this? 0.02. Okay, just to prove that I'm moving in the right direction and be cautious to see how this might react. I'm going to aim for half that. Okay, I'm going to aim for a change of 0.01. So I'm going to change this accordingly. Now in the controller, when I measured this with the TTC 200, it was measuring at 9.502. And again, I've heard that to not trust that number. So I am going to say that this is worn, not that. That'll stay 925, the shaft. I'm going to say this is worn by 0.01. So I'm going to subtract that from this. So that'll be 95125. Not a big change. I'm going to change this back to 2. Oh, 9.525. 9.525. Okay, not a big change. We'll see what happens. We'll sneak up on it. All right, I'm going to make that change here in this computer contour. Okay, and then we'll run it again. We're just finishing up on this first contour pass with the adjusted value, and now we should go down below for the second. And again, we've changed this by 0.01 in Fusion, and I don't hear anything. I don't think it's cutting at all. Cutting a little bit up here up top, but not really. This just sounds more, again, like a spring pass. No, now it's cutting. All right, we'll just measure it and see if there's a difference. So my third measurement is 40.005. So that's right on the money. Let's move on to the next example, which I am going to have to mill first. So for me, it's going to be about 30 minutes, and I'll be back. Okay, got the other side of this coin die done. Get a little measurement off this. Okay, it's exactly, and of course it is, it's exactly what it was on the first stop. So again, I want to, this time we're going to adjust wear, and instead of adjusting the tool in Fusion 360 by 0.01, I can adjust the wear in here by a negative value. I'm going to be doing a G41, tool compensating left of this die, climb milling, right? And so I want to compensate a negative 0.01 and then remeasure, and we'll see if that works. All right, let's go into our offsets. Let's go into our tool wear. It's 4.3. That's the tool we're using, or will be using. It should be highlighted, but right now I've got an engraving end mill in. I've got 8.1 in. So for example, if I, let's say, go to jog, machine, if I were to change this to 4.3, whoops, I don't want the calculator. back 4, tab 3, enter. Do a quick tool change to my 3/8 end mill, and it will update my offset. Okay, back in offset. 4.3, negative 0.01. I'm not in a hurry. Now here I can either hit arrow to compensate, or I can hit input, and then that data will be activated. Now, the program I'm running is this wear. In fact, while we're in here, I can show you the difference between, like for example, in Fusion 360 you have in control Inverswear, which I don't want. That's when it's a climb milling according to the Siemens manual, G42 command, and I want a G41 command. I'm sorry, an Inverswear, a G42 is conventional milling, and I want a G41 command, which is wear. Fusion 360 does post in control, but I don't know, I didn't see that in any of the literature for Siemens. And in the post, so for example, if we go in here and scroll down, in the post, it looks a little, well, it all looks funky, but I'll show you what it looks like here. It says, calls out G41, but then it has its X value. Now Siemens does an X and Y. It doesn't have like a P or a diameter value for the wear. This is actually a combination of what the X should be plus, and in this case, it's the diameter, either the diameter or the radius of, yes, the radius of the tool. So on the other programs, it would say X 1 point, let's say 9.1, but it's added that radius to here. So this is in control. Okay, let's go back. Now, I'm not using Inverswear, I'm going to use wear, and this is the difference. Let me page down to that G41 command. Oops, here it is. N460, G41, calling out wear, tool cutter compensation to the left of the part, climb milling, and then here's my X value, the 1.429. So that's what it looks like in the G code. And then on my offset, again, I've set this to negative 0.01. I'm going to point the camera at the part with my finger on feed hold, and we'll see how this goes. All right, here goes nothing. Okay, stop. Well, I did it wrong. I did it wrong, I guess. I've got an error here. And I don't know if you can make that out, but I'll read it out. It says, block N460, danger of collision due to tool radius compensation, 1644. Okay, so the post that I'm using from Fusion 360 for wear, that we went over, it just keeps erroring out. I actually I started control, and that seems to work. So the in control post from Fusion 360, again, I've got a negative 0.02 value, moving the bit closer to the workpiece. And I've got my hand on feed hold, fingers crossed. This works. Please don't break anything. We're gonna go run this part. Here we go. And already on this top contour, I think that's more noticeable than when we did it in computer. I mean, it's just observer bias here, me sitting here, N of 1. So there's that contour. I'm going to fast forward, and we'll do the real contour next. All right, moment of truth. Here's the The real, that's money. That is effing money right there, guys. That totally worked. And I actually forgot to mention prior to this, when fooling around, I tried the wear program with 0 wear, with a positive wear, and then when I re-entered it, I put in negative 0.02. So this should be the first and last adjustment. I'll measure it after this. Originally I was going to go halfway, but this is what happens. This is what happens in my shop. Let's measure this bad boy. This should be exactly, I'm shooting for 40 millimeters. And it's, whoops. Oh crap. And I overshot. Let me do that again. Yep. Let's do north-south. Yep. It doesn't matter on this part. What matters is I know that wear works. Guys, well, ultimately that was a success. I believe I understand a little bit better how to utilize Fusion 360 to leverage the wear functionality on my Siemens controller. I went ahead, just to summarize, I posted in computer, in control, wear, and Inverswear so that I could analyze the G-code at my desk in my office and then try them out. Now, my hypothesis was that computer would work, that I could update the tool library and then rerun the part, and that did work, and it was very controllable. And then that the wear toolpath would work, the G41 wear cutter compensation toolpath would work by updating my absolute wear in here to a negative number to get closer to the workpiece. That didn't work. I kept getting an error. I played around with some different settings. I added a positive number. I added a 0 in the wear compensation table, and it all errored out with, well, you saw the error in the video, but the controller recognized that my tool was going to impact the workpiece. But in control, the one that I didn't think would work, the G-code that I really didn't understand, but it makes sense because it is adding a diameter value in there. So of course that's the one that works, or rather a radius value. So that's the one that worked. Now, in my haste to figure this out, of course, I went ahead and fat fingered a negative 0.02. Now, I broke my own rule. I always try max going half the different distance, which would have been negative 0.01, and I think that would have been the number. You got to sneak up on it, and I did negative 0.02, and of course, well, the piece is still in the vise, I am 0.02 undersized. But it doesn't matter for this application. What matters is I'm confident now that using in control, the post on Fusion 360, and the wear table here, I'll be able to sneak up on critical high precision measurements. Anyway, as always, thanks for tuning in. Catch you on the next one. Bye.